Hey everybody, so this is about how to factor difference of squares. Okay, now in another video I showed you how to factor sum of cubes and difference of cubes. It's possible to factor sum of cubes. It's also possible to factor difference of cubes. Now for difference of squares, it is possible to factor them. However, for sum of squares, it is not possible. Okay, so you have to, the answer, you would say it's not factorable, and you would say it's prime, okay, or not factorable. By the way, see the other video I have on that, on sum of squares, so you can understand more on, because I explain more about sum of squares, okay? But now the focus is just for difference of squares. Okay, for this one here, it's pretty simple to factor. So you just need to go a minus b times a plus b, okay? Now, if you multiply, if you FOIL, in this case here, you will get a squared minus b squared. You can try, but if you do that, you will get a squared minus b squared, okay? So this is how you factor difference of squares, all right? A minus b, a plus b. It doesn't matter where you put the a minus b. It could be a plus b, a minus b, but you have to have both factors. And it makes sense because guess what? You guys, you know. So if I do 5 times 2, the answer will be 10, right? The same way if I do 2 times 5, the answer will be 10, right? So it doesn't matter how you put the factors, all right? Always remember that. So now, how about an example? Okay, well, let's solve this one here. So let's say example. It says factor. Okay, factor, and you have x squared minus 1 over 25. So x squared minus 1 over 25. So first thing to do here, guys, is to check to see whether you have perfect squares, right? Before you use these two factors there, okay? So it turns out that x squared is a perfect square, and 1 over 25 is actually a perfect square because it can be written as 1 over 5 times 1 over 5, which would be 1 over 25, okay? So same thing for x squared, can be written as x times x, which would give you x squared, okay? So we can use the formula, we can use what we have up there. So let's go to factor it. I just use x and 1 over 5. So it's minus x minus 1 over 5 and x plus 1 over 5. That's it. There's nothing else to do, okay? Because you just need to check to see if they're actually perfect squares. The first thing to check, then you gotta know that it's the square, the difference, okay? So this must be negative. These two must be perfect squares, okay? You must have a negative sign, and these two, the two terms must be perfect squares, okay? Remember that. So x minus 1 over 5 times x plus 1 over 5. Okay, let's try another one. I know this is very simple, but I wanted to make sure I cover it with you guys. So 18p to the fourth. Here's another one, number 2 here. 18p to the fourth minus 50t squared. Okay, 50t squared. 50t squared, okay? So 18p to the fourth minus 50t squared. All right. Now, for exponents, what you do is, as long as what you have is divisible by 2, you know it's a perfect square, okay? It can be written as one thing times itself, okay? So for the numbers, the actual numbers you have here, 18 and 50, the base is here. Now, you know 18 is not a perfect square. Now 50 is not a perfect square. One thing you know is that I told you when I started explaining how to factor, from my previous videos, what I said was that you need to make sure you check to see if there's a GCF. If there's a GCF, you must factor out the GCF, okay? Before you use any other method of factoring, you need to check for a GCF. In this case, there's a GCF. What's the GCF? 2. Between 18 and 50? 2, okay? Now, letters, no, because it's a P and a T, so they're not alike. Okay, so 2 is the GCF. Factor it out. After you factor 2 out, you will have 9 P to the 4th now minus 25 T squared. And when you check what you have here, right here in parentheses, you realize that 9 is a perfect square because that's 3 times 3. Okay, that's why you know 9 is a perfect square. It's 3 times 3. Now, P to the 4th is a perfect square because 4 is divisible by 2. Okay. 25 is a perfect square because that's 5 times 5. T squared is a perfect square because 2 is divisible by 2. Okay. So therefore, you can rewrite this as, and I'm going to rewrite it just to make sure it makes sense to all of you guys. So 2, I'm going to rewrite this as 3 P to the 2nd raised to the power of 2, because 2 times 2 will give you 4, okay? Minus 5T raised to the 2nd, right? Okay. Should make sense to you, right? Again, 3P to the 2nd raised to the power of 2, because 2 times 2 is 4. I just needed to see if it's divisible by 2, okay? Now, but I need to raise both to the power of 2, so I can use my formula here, right? So now let's go. I know the 2 is still outside, and I know I'm gonna have 2 factors, right? One with a negative, another one with a positive. Then I have to pick A. A is just 3P squared here, minus 5T. And what else? The same thing, right? 3P squared plus 5T. Okay, that's it. This is how you factor this. This is you factoring difference of squares. Okay, again, as I always say, try a couple, make sure you practice, and this should be pretty easy to you. Again, make sure you go ahead and now watch my video about sum of squares, okay? My video about sum of squares. Keeping in mind that you need to make sure you always look for a GCF, okay? Always look for a GCF. That's it. That's all I had for you. Difference of squares. Thank you.